Guys, welcome to lesson 2.13. We're going to talk about implicit functions today and how to integrate those. Okay, so now, in case you guys forgot, what is an implicit function? An implicit function is a function where the y value is somehow buried within the equation itself. This is what we call an implicit function. An explicit function is one where you have the y all by itself. Okay, and that's what we've been doing integrals with and stuff like that. You'll remember back in Unit 1, we treated them differently as well. We spent most of our time talking about how to find derivatives of explicit functions, but then we devoted a day or two to finding derivatives of implicit functions. Well, we're doing the same thing now, but with integrals. We've been spending most of our time talking about how to integrate explicit functions, but now we're going to talk about how to integrate implicit functions instead. Okay? And so that's our goal for the day, is how to integrate those. Now, before we do that, though, we need to review some pre-calculus skills here a little bit. We need to learn how to solve, okay, for a variable. Now, in all these problems down here, what we're going to do is we're going to solve for y. And in each one of these little efforts that we're going to be making to solve for y, you'll see some interesting little algebraic facts that you might want to take note of. So make sure you take good notes on these little pre-calculus strategies here. Okay? So let's go ahead and start with number 1 here. Suppose I gave you guys y squared minus 6 equals x. And I wanted you to solve for y. I wanted you to get y by itself. Well, most of you guys would know we want to start off by adding the 6 on both sides first, which would give me this. The next thing that we would want to do is we would want to take the square root on both sides. But here's where something comes up that a lot of you guys might miss. Now, you guys know that the square root cancels out the square. That's good. But something that a lot of people don't realize is that when you solve by taking a square root, you always get 2 answers, a positive and negative result. Okay? So that's something I want to draw your guys' attention to when you're solving an equation that involves a square and you have to solve by taking a square root. Don't forget to put a plus and a minus. So if I were a student after taking these notes, I'd put, don't forget the plus and minus. Because that's kind of the little thing to be concerned with there. We'll see that come up a few times today. Let's take a look at the next one here. Suppose I gave you guys sine of y equals x. How do I solve for y? Well, we need to do the opposite of sine on both sides. What is the opposite of sine? The opposite of sine is arc sine, believe it or not. Squish it in there. And whatever you do to one side, you have to do to the other, and these cancel each other out. And so the answer here would be arc sine. Y equals arc sine of x. Okay? Let's take a look at another one. Now, this one's really common, especially numbers 3 and 4, very common issues. Let's take a look at those ones. So I have ln of y minus 4 equals x. Okay, so step 1 is to go ahead and add the 4 on both sides. Right? And now we might be wondering, how do we get rid of the ln? Well, you have to do the opposite of ln, which is called exponentiation. Okay? Now, ln is a log with a base of e. So the way that we get rid of the ln is we make both sides of this equation a power of the base e. Whatever you do to one side, you have to do to the other. So they both become that. Now, why did we do that? Because, long story short, this and this kind of like cancel each other out, and you're left with this. All right? Now, we're actually going to go a little bit further, though, with this. typically this would be okay, but for what we're going to be working on in this unit, and especially for a lot of the FRQs we're going to do, they don't leave the answer like this. They take it a little bit further, okay? And this is not at all an obvious thing, but that's why I'm showing it to you. Okay, now first of all, I want you guys to remember this, right? If you have x squared times x to the 5th, what's the answer? Hopefully you guys know it's x to the 7th, okay? So in other words, x squared times x to the 5th, that's the same thing as x to the 2 plus 5, right? You add the exponents together. So I was working this way, but we can work the other way. Instead of having two exponents that are being added, you can split it up as two x's with separate exponents. So in this case here, we can rewrite this as two separate e's like that. Now, e is just a number. It's 2.71, and it's like an irrational number like pi, so it just keeps going. But if I were to simplify that, I would have e to the 4th power is about rounding it to the, I'm just going to round it to the 10th place. Usually in this class we like to go to the thousandths, but I'm just going to kind of keep it simple here and just say to the 10th place. E to the 4th power is about 54.6. So I want you guys to be aware of this little strategy here where we separate these two things into two separate e's, and then basically this part just becomes some constant number. Okay? That's a strategy we're going to use. So two big takeaways from this one. How do you cancel out ln? You exponentiate both sides. Second big takeaway, when we get to this step here, we're going to split it up and simplify. Okay? So those are two big pre-calculus review topics that I want you to be aware of. Let's move on to another one. Suppose I have 2 e to the y plus 6 equals x. What would I do to solve for y? Well, I would minus 6 first. Then what would I do? We divide by 2. Now what do I do to get y by itself? Well, at this point, I need to get rid of the e. So how do we get rid of an e? Well, remember how the e canceled out the ln? Well, guess what? ln cancels out e. So whenever you have this type of situation, you're going to take the natural log on both sides. Okay? ln cancels out e, and we're left with just the y. Now, just so you guys know, when we do this, it's going to be an absolute value expression, technically, because, you know, this can't ever equal a negative, but it really probably shouldn't end up being a problem in the long run. But for now, we'll just leave it at this. But there's that. And I would say that's probably going to be good enough, but just for fun, I want to review some log properties with you guys really quick, because every once in a while those come in handy. When you have a log that has a fraction in this argument, the stuff in the parentheses is called the argument. So when you have a fraction in the argument, you could write that as two separate logs, where you have the top and the bottom in two separate logarithms being subtracted from each other. Okay? So either one of those are acceptable. That's one of our log properties. Okay, which you probably should have seen last year in pre-calculus or in Algebra 2. Okay? But that's kind of like a not very important idea on this one. The important one is, how do you cancel out an e? You take the natural log on both sides. All right? Okay, let's take a look at number 5 here. We have the absolute value of y minus 3 is equal to 2x plus 4. the absolute value of y minus 3 is equal to 2x plus 4. Well, here's something we know, is that if this is an absolute value, right, that means this whole side here has to be positive, which means this whole side has to be positive, right, in the end. So let's keep that in mind. But typically what you do whenever you're trying to solve an absolute value expression is you're going to write the equation twice. Now, before I do that, let me just refresh with you guys some things here. So if I told you guys that the absolute value of y is equal to 2, what would the answer be? Well, what number has an absolute value of 2? There's two answers. 2 has an absolute value of 2, but so does negative 2. So y can be two different things. You could plug in two different numbers here so that when you take the absolute value of it, you get a positive 2. And that's how this problem is going to work also. Okay? So how you kind of want to think about it is basically just write this equation twice without the absolute value bars and just make one of them a positive 2 and one of them a negative 2, right? Well, we're going to do the same thing with this one that we're looking at right now. We have the absolute value of y minus 3 is equal to 2x plus 4. So I'm going to write that equation twice, but without absolute value bars. And one of them I'm going to make the right side, the right side a negative. Just like I did in the other one. And then we just are going to solve both of these. So we have y minus 3 is equal to negative 2x minus 4. So I distributed the negative there. And then I'm going to add 3 on both sides. And so we end up with y is equal to negative 2x minus 1. And there you go. So there's one answer. Now for this one over here, I would just add 4 on both sides, and I would get y equals 2x plus 8. So there's that. So that's our pre-algebra review there about how to solve for y and the little tricks and things that we're going to have to do to be able to pull this off. All right, so this is a differential equation. What is a differential equation? A differential equation is an equation where you have a derivative as part of the equation. So this is a differential equation. Furthermore, it's an implicit differential equation because we have a y value as part of the equation itself. Okay, so this is an implicit differential equation, and we need to know how to integrate these. Now, I just want you guys to know this before we go any further. These questions are extremely important for you to know how to do. Now, there's a lot of algebra in them, but here's the good news. If you guys mastered this, because honestly, the steps are the same on almost all of them, there's a few places where they get a little bit different, but for the most part, the steps are almost the same all the way through. This is very important. Sometimes on the FRQs, when you get questions that involve these types of questions, this question alone makes up almost 50%, if not more, of that one specific FRQ, which is amazing. Because usually, an FRQ question might only make up like maybe, maybe 10% of the FRQ. But these questions actually make up about 50% of the FRQ questions. So knowing how to do this is almost a guaranteed pass for FRQ questions that involve this type of math. So, downside is this. There's a lot of algebra, and sometimes it's tricky, but the good news is once you've mastered them, and we're going to do them a lot, so you'll have plenty of opportunity to get it, but once you've mastered them, you've pretty much got a guaranteed pass on one of your FRQs this year. So, it's worth spending the time to figure out how to do these problems, but it will take some time, okay? All right. So, and the good news is most of the steps that you do to solve these are completely the same from one problem to another. There is a specific spot where it gets a little bit different, but most of the steps are the same on every problem. So here is this first step. And I would highly encourage you guys to write these steps down. Separate the variables. Okay, what do I mean by that? Well, as you can see, we have x's and we have y's. So what you want to do is you want to get all the y's on one side of the equation and all the x's on another. So the first thing I'm going to do is I'm going to multiply both sides by dx. Because I have this x here on this side, the x squared, so I want the dx with that one. So I'm going to get rid of that. And that leaves me with dy is equal to x squared plus 3 over 2y dx. Now the next thing is I want this 2y on the bottom, I want that to be with the dy on the left. So once again, I'm going to multiply both sides by 2y. And now I've got my variables separated. On an FRQ, doing that alone is worth 1 point. So if you just do that, you've already gotten 1 point, separating the variables. Not too bad. And usually all it involves doing is putting the 2 up here and putting the dx over there. So that's almost always going to be the same. Okay? Now, let's move on to the next step. The next step is to integrate both sides. So now we're going to integrate 2y dy, and we're going to integrate x squared plus 3 dx. Okay? We're going to integrate both sides. Now this one, remember I told you step 1 was worth 1 point. Step 2 is worth 2 points. You get 1 point for integrating each side. Since there's 2 sides, you get 2 points. So let's start on this side. We're integrating y with respect to y. So that means basically we could just integrate it like normal. So you would add 1 to the power and divide by that number. And so we end up with y squared. Now I'm not going to put the plus c. I'll explain why in a minute. There it is. So if we integrate 2y, we get y squared. Now let's do the other side here. Same thing, add 1 to the power and divide by that number. And for the 3, we just put an x next to it. Now here's where I'm going to put my c. Okay? You do not need to put a c on both sides. Why not? Well, I mentioned it in an earlier lesson, but I'll say it again here. You could put a plus c here, but eventually you're just going to put these two c's together, C1 and C2. And when you put them together, guess what you get? You just get another C, a different C. And so why give them all these different names and stuff? Just basically, just know we're just going to have one constant, and that's good enough. So you don't need to put a C on both sides. Putting it on only one side is good enough, okay? But anyway, right there I would have gotten 2 more points. 2 more points on an FRQ. So I've racked up 3 points now by getting this far. All right, the next step. The next step, we don't really need to do the next step here. But usually what it is plug in your initial condition to find the C. But in this problem, we're not doing that. I'm still going to write the step. But you only do that if you want the particular solution. Now, the reason why I wanted to put the step here anyway was because we're going to do that later in the block, but also, just so you guys know, usually on the FRQ questions, that they almost always do that. They never ask for a general solution. But I'm going to start with general solutions just to kind of keep it a little bit simpler. But as you guys know, with step 3, basically they're going to give you a point that you're going to plug in for x and y so you can find c. Okay? But for now, I'm going to skip step 3, and we're going to move on to step 4. Now, step 4, here's what I really like about these things, okay, is that these first 3 steps, they're almost always exactly the same. And look how many points we've already gotten. That alone is almost half of the FRQ, and that's almost a guaranteed pass on that FRQ already. And those steps are always the same. And here's the even better news. The hardest step is step 4. And step 4 is not always, the reason it's the hardest is because it's not always the same. But here's the good news. It's the last step. So if you just stop and don't do step 4, you've probably still already passed your FRQ. Okay? Now the reason why step 4 is hard is because it's not always the same. Step 4 is to solve for y. Sometimes it's pretty simple, sometimes it's pretty hard. Okay? In this case, it's a little bit chill. All we have to do to solve for y is square root both sides. And don't forget, when you square root, what do we get? A plus and a minus. There you go. Now that one wasn't too bad, but some of them will present a little bit more of a challenge, and that's okay. But the good news is that that's also just 1 point. So even if you have a hard time with that, it's just 1 point. So that's 5 points. Most FRQs are worth 9. So even if you got just the first 3 steps, you pretty much have already passed that FRQ, and that's just 1 question. So it's pretty cool. I love these questions. As you can see, they take a little bit of time, and you have to know how to integrate. That can be a tricky step too, honestly. So you have to be sharp with your integration. But if you get past those 2 things, you're pretty much home free. Let's move on. I'm not going to write the steps again, but so hopefully you guys wrote them, but you can do it on the next one. So here's what I want you guys to do. I want you guys to go ahead, pause the video, and try this problem. When you unpause it, you'll see the solution. So I only wrote down the first 2 steps. Once again, we're not going to do step 3. We're not going to find the initial condition and plug it in to find C. And then we have step 4. And step 4 is the different step where it's not always the same. So let's see if you did it right. The first thing you would do is you would multiply both sides by 3. To get that y by itself, you would multiply both sides by 3. Now when you multiply the right side by 3, you have to multiply everything by 3. If you do that, these 3's cancel, and now we're left with y cubed is equal to 3x squared plus 3c. But you know what? We don't really need to write 3c because if you take some unknown number and you multiply it by 3, guess what you get? You just get another unknown number. So it doesn't matter. Now, if you want to make sure that you know that that c that you wrote up there is different than this one because you multiplied it by 3, you can put a little number there if you want to, like that's going to be c1 now. But I don't think they really care about that, so you don't have to. Now, the next thing you can do is how do you get rid of a cube? Now, I didn't talk about that in the intro. What you do is you take the cube root. Now, some of you guys probably did this, and this was actually my bad. I probably should have told you guys this in the beginning. When you take a cube root, you do not get a plus and a minus. Anytime your power is an odd number, you do not get a plus and a minus. Okay? Think about it. If I told you guys that y cubed is equal to -8, what's the answer? It can only be -2. Okay? You don't get 2 answers. You don't get a positive answer and a negative answer. You just get 1. And so, when it's an even root, you do get a plus and minus. But when it's an odd root, you don't. So that might be a little note you want to write down. I would circle that. Maybe if I were a student, put odd roots don't get plus and minus. So we only have 1 answer there. But that would be our final solution for that problem, the general solution. All right. Let's go ahead and move on to another problem here. Okay. Find the general solution. So step one, we want to separate the variables. Now, separating the variables on this one is a little bit trickier, but I'll show you how to do it. First of all, I don't like the way that the x is in the exponent with the y there, so I need to somehow separate the x from the y. How do we do that? Well, I shared the little trick with you earlier in the lesson today. You could write this as two separate e values, just like that. So instead of having e to the 2y minus x, you can have e to the 2y times e to the negative x. Just separate those two pieces of the exponent into two separate terms. And now we can separate the variables. So the first thing I would do now is I would multiply both sides by dx, which will cancel it off of the left side. And multiply it on the right as well. And then I would divide both sides by this e to the 2y to cancel that out. Now I've got my y's on one side and my x's on another. So now I have the following. I've got dy over e to the 2y, and I have e to the negative x dx. And then we integrate both sides. So now we're on step two. After we separate the variables, we integrate both sides. Now, there we go. For this side over here, we don't like that on the bottom, so what do? We move it up to the top, and we make the exponent a negative. Okay, now I'm going to do one side, and I'm going to let you guys do the other side, okay? I'm going to do this side over here, and then I'm going to let you guys pause the video and try to do the left side. So, for the right side, how do we do this? Well, it's a u sub problem where we're going to let the exponent equal a u. So u is equal to negative x, which means that du dx is negative 1, which means that du divided by negative 1, which is just negative du, is equal to dx. And then we have the integral of e to the u du, and it's a negative du, but I'm going to put the negative in the front. Now that I've done that, if I finish integrating the integral of e to the u is e to the u. So now I have e to the u with a negative in the front, and then we need to put the u back in, which was negative x. So here's my final answer. Now I want you guys to integrate this side. Pause the video, and when you unpause it, you'll see the rest of the solution. So first I said u is equal to negative 2y. Then we find the derivative of u with respect to y, which is negative 2. And then we get the dy by itself, so we have du over negative 2. We replace the negative 2y with u. We replace the dy with du over negative 2, but instead of putting the over negative 2 here, I just took the over negative 2 on the outside there and wrote it as a negative half. And then after that we integrate, and the integral of e to the u is just e to the u, so we have negative half e to the u, and then we replace the u with negative 2y. So here's my end of step 2 there. We've integrated. All right? So before we go any further, I just want to make sure that you guys are... Oh, actually, you know what? I think I have a boo-boo here. This is supposed to be an equal sign between these, right? Between the left side and the right side. So it's this. And notice I also put the plus c there, you guys. Notice I have the plus c. Don't forget your plus c on the right side. Okay, so there's our result now. I've separated my variables and I've integrated. But let's review, because Most of the stuff after this is kind of old news. I want to make sure you guys got the idea. So in the beginning, how do you separate the variables when it's like this? You split it up. So that's your first big thing I want you guys to be aware of. Also, over here, integrating these things, you're probably going to, if you ever have an e expression, probably going to have to do some kind of a u substitution with the exponent, okay? Anyway, so now that brings us to over here. Now our goal is to get the y by itself. So how the heck do we do that? Well, the first thing I want to do is I want to get rid of this negative half. How would I get rid of that? Well, what I would recommend doing is multiplying both sides by a negative 2. If you multiply by a negative 2, the 2 cancels the 2 and the negative cancels the negative. So now I'm left with this. But whatever you do to one side, you have to do the other. So you also need to multiply negative 2 here and here. Now, negative 2 times negative 1 leaves you with a positive 2. And over here, if you multiply an unknown constant by a number, guess what you get? Another unknown constant. You don't need to put 2c there. You could just put another c there because it's just an unknown constant. All right, now what do we do? How do we get y by itself? Well, I need to get it out of the exponent, and we talked about that earlier today. You take the natural log on both sides. Okay? And the natural log cancels out the e. So now I have negative 2y is equal to ln of 2e to the negative x plus c. And then we have one more step to get that y by itself, and that's just to divide the negative 2 on both sides. And so my final answer here would be y equals ln of 2e to the negative x plus c. Now in an FRQ, this is definitely good enough, but you could go a little further with this, honestly. You guys are probably like rolling your eyes and saying, no, Bailey, stop, really. But let's just say maybe it was like a multiple choice question. Well, as you guys know, unfortunately with multiple choices, they can be written in a variety of ways. And I like to help you guys remember your log rules a lot because they do come in handy. So I want to show you guys something interesting about this problem, but this is not that important. It's very much secondary, but I want to at least mention it while we're here. So this is our answer, right? I just want to show you some interesting little algebra moves you can do to write your answer a little bit differently. Well, I can rewrite that like this. It literally means the same thing. So instead of putting it over 2, you could make it multiplication by a half. It's the same thing. Now, why would I want to do that? Well, I don't know. They might write the answer like that. But here's another reason. When they put it in the front, there's a log property that says anytime you multiply a log by a number, you could rewrite that as an exponent on the arguments. Okay? What else can we do here? Well, as you guys know, negative exponents make reciprocals, don't they? Negative exponents make reciprocals. So instead of being to the negative half, you could write it as 1 over that expression to the half. And then finally, what is a half power? Well, isn't a half power just a square root? Now, does this matter? Like I said, no, this is not a big deal. But I'm just showing you guys all the different ways the answer could be written. If you were on an FRQ, I would beg you to please stop here. There's no sense in going further. But this stuff I'm showing you just in case on some off chance you might need to manipulate your answers a little bit to get different looking answers to fit the multiple choices that could happen. Okay? All right. So what was my point in assigning this problem? Well, it was to give you one where the integration was a little bit trickier, but also that little trick there of separating those. Everything else was just kind of secondary. So let's go ahead and see how you guys do here. Now, for you, you don't have to separate the x and the y the way I did because they're already separated for you. All you have to do is just divide. But go ahead and pause the video here and see how far you can get. I'll put the final solution up, and when you unpause the video, you'll see the total answer. So I've got the first two steps completely worked out there, and if you didn't get this by the end of your second step, you might want to pause the video and study what I've done here and make sure you're good. But I'm going to skip step 3 because once again we're just finding a general solution. But step 4, we're ready to solve, and I'm going to go ahead and get started here. So the first thing I would do is I don't like this negative in the front, so I'm going to multiply everything by a negative. And so that's going to give me e, positive e now. The x squared becomes a negative x squared, and when you multiply a c by a negative 1, you can change it to minus c if you want to, but I'm just going to keep it as plus c. Because once again, it's just some unknown number. It doesn't matter what you do, it just stays an unknown number. All right, the next thing I would do is I would take the natural log on both sides. I would ln both sides. So I would do ln, and I would do ln. These cancel, and I'm left now with negative y is equal to ln of negative x squared plus c. Then the next thing I would do is I would divide both sides by a negative 1 or multiply both sides by a negative 1. And what am I going to do with that negative there in front of the ln? Well, you could just leave it, which is fine. That's a good FRQ answer right there. Or you can make it an exponent. And once you've made it an exponent, since it's a negative 1, you can make it a reciprocal. And so it's possible they would write their answer like this. Just like that. Okay? All right, so that's that. And I intended to go a little bit further with this lesson, but I think I might stop here and let you guys go ahead and practice this stuff for a little while. And then we'll kind of split this lesson up over 2 days because it's really important, and I don't want to burn you guys out, and I want to make sure that you guys get a lot of good practice on this because, like I said, it's worth a ton of points, so it's something I really want to make sure you guys have gotten mastered. So why don't we stop here while we're ahead and leave it at that. We'll see you guys next time.